science, get it?
No,
What? Law, Western movies. Lost.
No, they don't.
Lost on you. Lost on all of you. All right, so here's what happens.
We're young, so we don't get
Law of signs, I don't worry about it written in that form.
I'm getting kidding.
Come on, guys. Again, law of signs. We use law of signs to solve triangles that are not right triangles. This is nothing more than a real nasty ratio. It's all proportions. It's all fraction equal fraction. It's cross multiplying and solving. This is nothing that you guys have not seen. Take the sine of an angle is to its side opposite, is to the sine of another angle, to its side opposite, is the sine to the other angle, to its side opposite.
I did so good on this last week.
Good. Then what will happen in this case here, we take it one step further. Before, when you guys worked with law of signs, you worked with the cases that always worked. Now there will be possibilities of law of signs not working, or it might happen to be where you have more than one triangle. So there will be some extra parts in here, but what I want to do first of all is kind of walk you through, again, how you set up and use law of signs, how you use it in terms of the case of when you have to use the inverse button, when you don't have to use the inverse. Man, the glare is horrible today. So let's look at an example. Now leave the blinds open, this is fine. What'll happen here, oops. What'll happen here is that you're going to be given a statement, triangle ABC. You're going to be given information out of that triangle. Obviously, the easiest thing to do whenever you're given these types of problems, draw a diagram. Let yourself see what you're doing, because eventually, when you're not sure, there will be specific cases that you have to verify that make sure that this works. The more we get in the habit of drawing our diagrams, the better off we're going to be. No, this is not the scale. I'm doing just drawing a triangle. I don't care what it looks like. I'm doing a visual representation of a triangle. That's all it is. Fill in the blanks. And remember, the lowercase letters go opposite the uppercase letters. That's showing that it's the side opposite. Okay. Now, in a triangle, there are 6 sides. We know 3 of them. One of the other three things we have to find is really, really easy. It's that third angle. How do we find the missing value of A? So, easiest thing to do here when you're given 2 angles is find the third angle right away to get 49.
49.
All right, that's the easy stuff.
I got 60.
Now, come on guys, throw it. When you set these things up, then just reuse your givens. Okay? Constantly reuse your givens. In this case, I'm given angle B and the side opposite it. Sine of 28 is to 26, as the sine of 103 is the side C. I'm going to solve for that one first. Fraction equal fraction, all you got to do is cross multiply. And then how do I get C by itself? Like that. And that'll give me my value of C. Again, this is straight calculator work. But you need to make sure you write out what you're doing, that way we can see it, make sure we're not putting in the wrong values. You can type that directly in your calculator as a fraction. It'll work just fine. Make sure you're in degree mode, otherwise bad really won't work. So 26 sine 103 over sine 28. And there's your answer. Side C is 5396. We always round up 2 decimal places. Okay? And then basically do the exact same thing to solve for little a. Sine of 28 is to 26. Sine of 49 is to A.
Would you end up getting for some 53? Yeah.
53.
Alright, so just make sure.
And then you just have to type it out. And if I'm not mistaken, like I said, this isn't anything new that you guys haven't done. .8 when I round it out to 2 decimal places. It's .796. That rounds up to .8. Okay. And I'm done. Excuse me. What's wrong? Okay. Like I said, this stuff you guys all did last year, and if I'm not mistaken, you probably flew through most of it. What becomes a little bit more involved, a little bit weirder, is when you have to worry about the different cases that could occur. And this is where law of science kind of has a bit of a flaw. Law of science is going to work just fine when you have angle, angle, side, or angle, side, angle. Basically, law of science works great when you have two given angles and one of the sides opposite it. What happens is when it doesn't work really great is if you have three sides, or two sides and the included angle, where some weird things occur. And this is where all the cases come into play. This is what we call the ambiguous case. This is when you have to be really, really wary about side-side angle. When you have side-side angle, you have to be careful. When you're talking about side-side angle, it means you'll be given two consecutive sides and then a non-included angle. Okay? So you have to watch your side-side angle. Okay? Now, I left these things up on the board here because what's being discussed in this instance with don't worry about the scrunchy face.
No, I'm so okay. So like nothing.
What this is telling me here is that you're given. What this means is you're given an angle, and the side opposite it, and another side. This little a in capital A coincide with a given angle and its side opposite. It may not be always written out as angle A. It could be angle C, given side C. It's just saying all it is that the given angle is obtuse. There's two things you have to worry about. If the side opposite the given angle is obtuse and yet it's shorter than the other side, the triangle cannot exist. Because remember, small or largest angle would have to have the largest side. If you have an obtuse angle in a triangle, can any other angle be bigger than it? No. That's why it doesn't work. If it happens to be greater than the other side, then it'll work out just fine. Okay, it'll work out just fine. What happens when you're given an angle that's acute? That's when you have four specific things that could happen. Two of which you have to use sine. The other two aren't that bad. Or excuse me, three of them use sine. Well, one of the first things you always want to just check is if that side opposite your given angle is larger than the other side, then you're good to go. You have one triangle. If it's not, then you have to double check to make sure that the other cases work. And this is something you have to know. What they're doing here is basically taking the side not opposite the given angle times the sine of the given angle and checking to see what happens, which one of those three occur. It's weird. It's something you really haven't quite done yet. And that's why I'm leaving it up on the board for right now. So as we go through these next few examples, we'll refer back to them. So let's look at a nice example. Triangle ABC is given. and angle C is 122. Little c is 18. Little a is 12. So this is what it looks like to have the side-side angle. Right? So you just check it out. Is the given angle acute or obtuse? Obtuse. My given angle is 122, and it's obtuse. So then I look at the other two sides. Is the side opposite the 122 versus the 12? Is it smaller than or equal to 12, or is it greater than 12? It's greater. Since it's greater, will this triangle exist? Yes. That means this will work. Okay? Since it's greater, that means it'll work. So now that I know it'll work, I can go ahead and solve my triangle. Again, what I'm going to do in this case here is I'm going to solve for angle A because I have the side opposite. Once I solve for angle A, I can quickly and easily subtract out and figure out what side B or angle B is, and then use law of sines again to find the other side. You did this work before, but what happened was that this always worked. What'll happen now in this class is that you'll have to check to see if it will work. Okay. So let's set this up.
If it doesn't, we just like,
Correct. Sine of 122 is the 18, as the sine of A is the 12. Now yesterday when we did these problems, when you had to solve for the actual angle itself, what button did you have to press on the calculator? The what? Yes, you had to press enter. Prior to pressing enter, you had to press what? What was the buttons you had to press to find the missing angle? Well, sine, cosine, to what?
180 minus
Inverse, thank you. We're going to use the inverse button. Same thing that goes through here, guys. Notice, it's fraction equal fraction. So when it looks like this, all I need to do is 12 sine 122 over 18 is the sine of A. Once you write that out, all you need is your calculator at this point. Because you can type that directly in. 12 sine 122, hit enter, divided by 18, and hit enter. So I know that the sine of the angle A is going to be 0.56 and change. In order to figure out what the actual specific angle will be, all I need to do now is hit second sine, it gives me my inverse, of my answer. 3443. Hit second negative button. The answer button is going to be your best friend with a lot of these. Okay, that answer button is going to be your best friend when solving out a lot of these problems because you don't have to worry about writing down digits or anything like that. It's already stored in the calculator. You can just go from there. So that gives me 3443 for my angle A. Now I can just add them all up and subtract it out to get B. So that'd be something 0.57. So we'll wind up with a full, we have 3, 23, thank you. 2357? Is that right?
Yeah.
Okay. So now, once we figure that out, now I just have to solve for side B. Again, sine 122 over 18 is the sine 2357 is the B. What I'm doing in this step here, I don't know if you guys are recognizing this, I am skipping a little bit of the showing of the algebra. instead of rewriting out multiplying b times the sine of 122, I know that I'm going to have to divide by the sine of 122 at the very end. So I'm just saving paper. I'm saving ink. 839? And then, again, you can easily verify just by looking at just the smallest angle at the smallest side, largest angle, large side, and so on, just to kind of get a rough idea if it kind of makes sense. If it doesn't make sense, you might have done something wrong along the way. Okay? So just take a brief second to look at that. Again, this isn't anything that you guys haven't done specifically. It's just we're going to take it a little bit further with having to check our different parameters. Right? But you gotta be in degree mode. You've gotta be in degree mode. All right.
Wait, you got 8.3, not 8.4?
What'd you get?
I know, I got 8.4.
Wait, can you go back real quick? Just to the word.
18 sine 2357.
Yeah.
18 sine 2357 over, oops, divided by sine 122.
So you didn't need to do the negative sign on that one?
Yeah, I got that's what I got.
No, you don't have to do the negative sign on that because you're not finding the angle. You already knew, you knew both angles.
Gotcha.
That's not what I got.
849.
That's what I got.
What's not what I got?
849. Yep, should be 49. Okay. Yeah, the only time you have to hit the inverse button is if you're actually solving for the specific angle. Other than that, you don't need to worry about inverse. Okay?
Why did you pick why did you pick
I don't know.
I put the same numbers in.
You would, it would be, if she was ratings, it would be way off. Oh, you don't try and do it right away. You have to hit the enter and then divide. Okay? All right, let's try another one. Same basic principle. We're going to be given information. We're going to draw up a quick diagram and go through our different checkpoints. I have triangle ABC. Little a is 4. Little b is 2.5. And angle B is 58. So, yes, this is side angle. Again, is the given angle acute or obtuse? It's acute. My given angle is acute. 58 is acute. 58 is acute. So that means these are the two parts I'm working with. The 58 and the 2.5 will be the sides opposite the given angle. So the first thing I want to check is the given side larger than the other side given to me? Or excuse me, the side opposite the given angle, is it bigger than the other one? No, it's not. So I know that I can cross this one off. Because that's the easiest one to check. Remember, this A value is the given side opposite the given angle. It's not bigger than the other one, so I know that's not going to work. So I check the other ones. So I take the opposite side, 4 times the sine of the given angle, and I check to see what that equals. 3.39.
I got that one right.
Now, is that value, this value is then, oops, is it bigger than the other side?
And then you decide.
No.
No. What we're looking at here is, it is big, I'm sorry, you're right. It is bigger than the given side. I'm sorry. Sorry, but I was looking at a different problem. Again, we're looking at here, what's going to be weird is that they dummy it to a generic statement of side A to side B, but not always are you working with side A and side B. Sometimes you're working with angle B and side B, angle C and side C, things like that. So you have to rework the idea of what the problem is.
Wait, which one did we just did the top left one up there?
Yeah.
Wait,
So-
Since I knew that the two side, I knew that the side opposite the given angle wasn't bigger than the other one, I went to the first one and I just typed it in. Is the non-opposite side times the sine of the given angle, is it bigger than the side opposite the given angle? It's a lot of words for something that looks like it should be very easy.
what happened? What would have happened if it wasn't bigger?
If it wasn't bigger, then one of the other two parameters would have occurred. It would have been, we could have had possibility of creating two different triangles, and that'll come up from time to time. It could have been equal, and then that means you just have one side. If it's equal, it actually winds up being a right triangle. Okay. As you build into this, this is new. This will probably take a day or so to get accustomed to the way this stuff is gonna go through. Okay. Let's try it. Let's try it out. So we have what, a couple minutes left?
13.
We got
There.
12.
13.
All right. Let's try this then. I have all of that. I just really
No.
I can try Yeah, let's go down. Okay, cool. So again, when we set this one up, first thing we're going to look at is the given angle, acute or obtuse. It's acute because it's little.
Alex.
So it's acute.
Angle would be acute.
Oh, you're so sweet.
I disagree.
Nobody likes you, Willis.
Well, that's not it.
My mom said the exact same thing.
So again, well done. Again, we're just gonna start checking them. All right, take the side that's not opposite the A.
So 160.
160 sine of 70 with 155. What do you get? 150.35. All right. So it's smaller than it, okay? So it's 150 point something. At this point, I don't really need to know what the values are. All I know is it's going to be smaller. Now, is that smaller than the 155? Is that also smaller than the value of the other side?
Yeah.
Oh,
Yeah. So what happens in this case then is you get the possibility of running into two triangles. Okay. So here's what we do. Let's set this up to start out with that, excuse me, define angle C. And we might find out how this goes. Okay. So let's see. So let's see, I get 160 sine of 70, hit enter. Divide that by 155. Inverse my sine of that answer. 79.93? 75. Yeah. All right. Now, what does that give me for my possible value of B?
Yes, I'm glad.
34, what was that?
3407.
Oh, you said 3479?
0.07.
Sorry. Okay. And now could you go and find side B? I think what we might do, because we're going to run out of time here real fast, and getting that other triangle is going to be messy. If you come across a two triangle problem tonight, No, start it, and then I'll show you how to find the other variants tomorrow. Because I didn't get that far with the other class, and I don't want to get too far ahead of everybody else.
Is that in
So-
our book?
What's that?
Is that in our book?
Yeah, it's all in your book. I cut this stuff down because I know we are about to run out of time here, and I don't want to get too far ahead of the other class. Let me do this. Okay, let's work on those for this evening, and then we'll build off of this throughout tomorrow and whatnot to kind of recheck how we get into solving the two specific possible triangles. Okay, we'll just go off of that one, then we don't get too far ahead. Okay? They're actually pretty straightforward. The first four questions are, what are the possible triangles you can have? So you're basically just checking these parameters. The next four are using law of sine, and the last three are the last four of them are looking at a diagram and trying to use. It's very similar to working with the elevation and depression, but using law of sines instead. Okay, what's that? Yeah, please.